does, and then manipulate the destination. The other things we try to pry open, and these are not the most exhaustive set of things you could try to pry open a redirect. We tried some very naive things, if you will. So the other things we tried was we dropped the other query parameters, and either we dropped them or we altered them in very trivial ways, which I'll describe. So what have I covered so far? Given a link, you need to have some heuristics to determine if it contains the HTTP dynamic redirects, because that's what we are focusing on for now. And we looked at only a subset of it, which is simple redirects, where you can predict the destination of your redirect by looking at the link itself, and you verify it. So you actually traverse to make sure that your redirect is actually a redirect and it's a simple redirect. Once we confirmed that a link contained an open a redirect, we applied very simple heuristics to either find if it's open or to tweak it just a little bit to see if we can make it become open. Right? Okay, so now for how we went about actually conducting the study. This is sort of the background. We actually did web crawling. So we started with a list of URLs. We downloaded that page, all the links on that page, and all the links from that page, from those links. So essentially 2 levels deep. And we stayed within the same domain. So if the original link was ebay.com, you go to eBay's first page, you retrieve all the links on that HTML page, then you take those links, but then you traverse those links 1 level deep further, and then you get another set of pages that have other links. We retrieve those links also, but we did not click on the link if it was taking us to another domain. So if ebay.com has a link to paypal.com, we did not traverse that. Staying within the same domain, we basically did 2 deep on every page that we traversed. And then we had a big collection of links. Then we applied our heuristics to find redirects, to verify that we were correct, just simple redirects, and to pry them open and to find if they're open. So we used 3 initial URL lists because we wanted to traverse it's a small fraction of the web for how big web is, but we wanted to not do a few hundred or a few thousand pages. So we traversed a fairly large data set here. So Alexa is a web information service, and you can actually go to Alexa to find out what are the top 500 pages that are most popular. Or Alexa has 16 different categories. You can say what are the 1,000 most popular pages in each category. So what we did was we looked at top 500 popular pages on Alexa and top 1,000 pages in each of the 16 categories that Alexa has. Then this is one data set that we use for original list of URLs. The second list that we use was there is a DMOZ Open Directory project. So this is a project that has the goal of collecting URLs that people visit. So a URL that you often visit or you visit, you may contribute that URL to the DMOZ directory project, Open Directory project. And they have, I think not that many really as proportion of the web, but they have many million links that users have contributed, and anyone can download those links. So we found user submitted links from that, and those were all our starting pages. So these are 2 sets of starting URLs we used. The third list of starting URLs that we used was DNS queried issued by our department. So if we saw a URL, a domain that people traversed, we looked at which domains they went to, and we started with those as first pages as well. So these were the 3 data sets: popular web pages, the pages that the domains that people in our department traversed, and the links that were submitted to the DMOZ Open Directory project. So we hope that this gives certain sampling of the web as it exists. So in Alexa data, we had close to 1 million links, million pages that we started with. DMOS, we had a smaller set, 216,000 pages, and the DNS actually, the domains, the pages that our users visited, was actually the largest, which is close to 1.4 million pages. So these are the number of pages. So how many links did we end up with? This is close to 140 million total links that we actually examined for the study. It turns out that 70 to 75% of them, at least 2/3 to 3/4 of them, don't have a query string, which means they don't even have a query string, so they can't be a redirect. And they can be a redirect, but they cannot be a dynamic redirect for sure. So we eliminated at least 70% of the links from each of these data sets. And even when there was a query string, in many cases, the query string did not contain a URL pattern, which is there was no http://, which doesn't mean that it cannot have a dynamic redirect. However, given that we are looking at just the simple dynamic redirect, it certainly did not have a simple dynamic redirect. So we ruled those out. So out of the 140 million links that we started with, somewhere between 1 to 2% of those actually looked like what could be a redirect, dynamic redirect, right? So we looked at those. Then, remember we said for query strings, we'll look at a question mark, and then we'll look for http://. So when we looked at that, then those 1% numbers, if you remember from the previous slide, you don't remember those numbers. We had a little less than 300,000 potential simple, dynamic simple redirects in Alexa, 20,000 in DMOS, and about a little over 500,000 in the DNS data sets. So how many do we have? 850,000 or so links that contain dynamic and simple redirects. We haven't traversed them yet. All we think is using our heuristics, these should contain redirects. And then we actually traversed them through a library and verified that the destination contained in the link, whether that was the same as the destination in the location bar after we visited, right? So it turns out that our heuristics actually identified somewhere between 58 to 68% of the links that we thought contained a dynamic redirect actually did contain dynamic redirect. But the others, they were not what we thought they were. But out of these 850,000 potential redirect, 2/3 of them were actually redirects. So our heuristics are reasonable heuristics to identify a redirect. The rest were either not redirect, and it turns out that some of those links are broken because these data sets are not real time. This link that you have in DMOS was maybe submitted a year ago and maybe is inactive. Not everybody is making sure that every link they promote on their website remains active, right? So it turns out for DMOS data set, if you notice, there were about more than 1/5 of the links were actually broken by the time we traversed them. So the fact that we only see our heuristics identify 2/3 of the links as redirects doesn't necessarily mean that the heuristic is bad, because in quite a few of the cases, the link itself is broken. But here we have some redirects that are simple, so you can predict the destination of the redirect, and they're dynamic, and now we want to test if they're open. True? So essentially, across these 3 data sets, we found over 500,000 actual redirects, actual simple and dynamic redirects, which means, once again, that there is a destination contained in those links that matches the destination of the final page that you end up in, right? There was a question? Yeah.
See, you have explained a while ago, represent a sample, right? Is the sample. And so...
Did you press the mic just to be sure?
No, I didn't. Do you want me to press?
So let's start
Yes,
again.
I can hear.
All right. So is there any kind of mathematical approach to create this sample in order to represent the whole population?
So the question is, can you